Welcome to One Chemistry. Always try to do your best. Now let us see about 100 conversion in organic chemistry. We are seeing it as episode. This is the episode number 61. If you didn't watch previous episode, I encourage you to go and see. It will be easy and simple. Here we solve 5 problems step by step. Stay tuned. Let us see the question number 1. The starting metal contains hydroxylamine with one side with 2 bromines attached on the end. Here you are using the base and alkyne. Then you are using the bromine and sodium borohydride. Here they ask you to find the products. The products are mostly cyclized one. The way of cyclization here is important. The cyclization happens in the regioselective way. NO or ON is bonded or not. Real question here. Then the fate of bromine and hydroxyl groups also in the question. Many functional groups are available, hence many directions are possible. Then definitely cyclization occur in the reaction. The answer is A. Let us see how. The starting metal contains hydroxylamine with bromines are attached. The nitrogen have lone pair. Bromine is a good leaving group. So what really happens is nitrogen donates, bromine leaves, and new triple bond formed. Nitrogen acquires the positive charge. Next step, you are using the base. Base abstract the proton. So it's a kind of halide formation. The positive or negative charge will be there. So oxygen possesses negative, nitrogen possesses positive. Here you have 2 triple bond and the charge. You might guess it's a dipolar addition reaction. So 1,3 dipolar addition reaction. The alkene bond rotates there. Here the alkene can bind in the any way. So the 1 or 2 attack of oxygen is possible. So regioselectivity is the matter here. But oxygen has negative charge. The 1 carbon is electron deficient. Because carbonyl group is electron withdrawing group, make the 1 carbon more nucleophilic. So the attack is happen on one ring closer and the oxygen bonded with one fashion. So oxygen, the 1 bond formation there, and the side the ketone will be there. Next step you are using the bromine. The bromine, whether it will add on the ring or add on the side chain is better. Here you are not using any ring activation using Lewis acid. There is no Lewis acid which is FeBr3. So no ring substitution, only side chain reaction. So bromine substituted on the side chain. Next step you are using the sodium borohydride, which will only selectively reduce the carbonyl group there. So it reduces C11O to COH. So the answer is clearly A there. Here you have to learn 2 important things. One is dipolar addition and its reactivity. You have to find the reactivity based on the nucleophilicity. You have to decide based on the where electron withdrawing group is there. Next thing is without the ring activation, always substitution happen in the side chain. Then the question number 2. The starting metal is bicyclic system with conjugated ketone. On the fused carbon you have thioether there. Here you are using methyl iodide and base. They ask you to find the product. The products are mostly methylated one on the alkene side, and sometimes the sulfur also left in the products. So C is complete elimination of sulfur. D is the methylation at CO double bond. So definitely the question is about methylation. So you have to understand that there is a role of stereochemistry because the bonds are specified and its relationship with methylation also in the question. The answer is B. Let us see how. You have thioether and you have methyl iodide. So what really happens is the methylation at sulfur will happen. Sulfur possesses the positive charge. Sulfur acquire extra valency, it possesses positive charge. Then the proton abstraction is happening. So the positive charge is there. So proton abstraction at the methyl group. So CH2 minus will be there. Then you have CH2 minus as well as you have the conjugated ketone. So intra addition reaction is possible. So 1,4 addition is favorable here, not 1,2 addition because it's a soft nucleophile. So soft nucleophile always favor the thermodynamic product which is 1,4. So 1,4 attack happens and the new CH2 bond formation is there. Again the ring is more strainful, the ring has to be opened. So the ring strain is a driving force here. The charge also has to be quenched here. So charge quenching and strain promote the ring opening again, charge travels, ketone formation again, and the methylation on the plane. Here methylation happened above since the sulfur group also above the plane. So both sulfur and methyl are above the plane. So the answer is B. Here you have to learn two things. One is intramolecular 1,4 addition. Second thing is charge quenching. The charge quenching always should happen with any possible way. Here the ring opening and methylation. Then the question number 3. Here the starting metal is cresol with base they given, and the next reagent is alkene with side chain chloride. The next step you are using heating and palladium and copper catalyst. They ask you to find the product. The products are mostly new CC bond formation is occur, and the ketone also established in the side chain. So definitely side chain the carbon skeleton is changed. So from the reactant and product you might guess so naming reaction is involved, and carbon skeleton change in the side chain is the real question. The answer is B. Let us see how. Starting metal you have alcohol and you are using the base. Base subtract the proton and the alcohol, you have charge. Next one you are using the chloride, which is alkene chloride. You are using the negative charge. You are attacking it with negative charge. So new bond formation occurs. So new OC bond formation is occur. You have the O alkyl group. Then you have double bond and oxygen. There is a possibility of rearrangement. It's a kind of Claisen rearrangement, or you can say simply 3,3 sigmatropic rearrangement. So the charge travels and the 6-member transition state favors the new bond there. Then you have the ortho shift of the alkene will be there. Here alkene became end one, 2 methyl groups are in the second position. Next step, aromaticity has to be established. So hydrogen leaves and aromatization happens there. So aromaticity occurs there. Next step, you are using the palladium copper catalyst with oxygen and water. So you might know it's a Wacker oxidation. You have alkene, you are using palladium and copper catalyst. So definitely CO creation will be there. So the answer is clearly B. Here you have to learn two things. Whenever you have benzene with double bonded system, you might consider the sigmatropic rearrangement. Next thing is Wacker oxidation. If you have the alkene, you are using palladium and copper catalyst, you might imagine the Wacker oxidation. Then the question number 4. The starting metal is 6-member ring with hydrogen, alkene and O-methyl also in the chain. Then the long side chain is there with sulfur dioxide and hetero nitrogen groups also there. Here they ask you to find the product, and another reagent is long chain alkene with TeSO and CHO. Your reagent is sodium salts of hexamethyl disilocene. Here 4 products are given. 4 products are only differ in the alkene stereochemistry. Alkene configuration, either it can be cis or trans. Either double bonds are in the question, whether the first double bond is cis or trans or second double bond is cis or trans. You can say E is that, comfortably we say cis or trans. So you have to know the naming reaction and stereochemistry is involved here. The answer is B. Let us see how. The starting metal contains long chain side chain with hydrogen. You are using sodium salt or HMDS. It is called Julia olefination. It is a kind of Wittig reaction. End alkene will be formed. But let us go step by step. You have the anion formation since the proton abstraction. So anion is formed. You have another starting metal contained the ketone there. So ketone is there, negative charge is there. You are attacking the carbonyl. So carbonyl attack will be there, and new CC bond is formed. So the long chain attached with the side chain of the system. Then you have alcohol and you have the leaving sulfoxy groups. So the alkene formation is there. This is the important step in the Julia olefination. If you are more curious, go and study separately. Here Julia olefination always prefer E alkene. So E alkene is formed there. The side chain won't have any effect on the system. So side chain remains same, which is Z. So E and Z configuration. The product is clearly B. Here you have to learn two important things. One is Julia elimination. Julia elimination, you have to guess what is starting material, which is sulfoxy compound, and it is always end with the E configuration. It's a very important thing. It is a simple reaction. They threaten you with big structure. Then the question number 5. The starting metal is benzaldehyde and you are in the 5-member cyclic system which contain quaternary ammonium salt and sulfur. Here 2 hydroatoms, nitrogen and sulfur is there. Next step also you are using the aldehyde, which is a heteroaldehyde. Then you have 4 starting metal. So the reaction shows the condensation is occur. The which way condensation occur is the real question. So which oxygen become ketone there or which oxygen get reduced there. Here many possibilities, but the reaction is simple. The answer is C. Let us see how. The starting metal is a hetero system. You are in the base. Since to quench the charge, proton abstraction will be there. You kind of stabilize the halide formation. Then the negative charge attack on the carbonyl. So you have carbonyl attached. To simplify this, we written phenyl group as pH. So new CC bond occurs there. Next step also again you are in the base. Since the hydrogens are available, again the hydrogen will be removed there. So again alpha hydrogen is removed. Next step you are having again a ketone. So negative charge attack the ketone. You have new CC bond. So 2 new CC bonds are occur consecutively. Then you have alcohol, which is diol. You have to guess which group will leave there. There are many heteroatoms with carbon. So which groups will be leave there? You might know the charge system is very much unstable. It has to be quenched by any way. So what really happens is it leaves first. The hetero ring with diheteroatoms leaves there. So OH and the hetero ring leaves first and it forms ketone. So the product is clearly C. Here you have to learn 2 important things. This reaction is so simple, it is aldol condensation. But you have to be very bold to solve the problem. By looking at the structure and problems, you should not get intimidated. The second thing is which group leaves. That is also a real question. Which group leaves? Always self-stabilized group or charged groups leave it to stabilize itself. That's all from this episode. I hope it was easy. Thanks for watching. If you have any suggestion, comment below. Stay tuned for next episode.